kicking off the day. It's my absolute pleasure to introduce Electricity Maps to you. Electricity Maps is a global API platform that allows connected devices to reduce their emission and costs by informing them about the best time to consume electricity. Théo Egal, he is Business Development Manager at Electricity Maps. He will explain how consumer electronics companies can create smarter products that optimize energy use. Welcome, Théo. The stage is yours.
Good morning, everyone. Thank you for joining this morning. Thank you for joining this presentation, and thank you for the introduction. My name is Théo. I'm a Business Development Manager at Electricity Maps. And today I want to talk about how to build the next generation of sustainable products. I want to start this presentation by talking about a fact that, in my opinion, is underestimated or overlooked when talking about sustainability for consumer electronic products or for electrical products, which is that we live in a world where the carbon footprint of electrical devices varies in real time. What does that mean? Well, that means that the CO2 emitted by an electrical devices or a consumer electronic product changes throughout the day. That means that how sustainable a product can be changes throughout the day. Why is that? Well, electrical devices consume electricity. Consuming electricity does not generate any CO2, but producing electricity does generate any CO2. So if you charge your phone in an hour, or if you charge your phone this evening, that might have a completely different impact, and that might generate different CO2 emissions. If you charge your EV tonight when going home or tomorrow morning, that might as well have two completely different impacts. So the reason that CO2 footprint of electrical devices changes throughout the day and changes over time, well, it's because the weather changes, right? The wind doesn't always blow, the sun does not always shine, which makes wind and solar power to fluctuate. We know that wind and solar power are low carbon source of electricity, are source of clean electricity, but they need specific conditions to run, and they need specific conditions to produce electricity. So when these conditions are not there, we need alternative ways of producing electricity. Right? A country can either turn on its coal plants, turn on its gas plants, or import electricity from its neighboring countries that might produce also with coal or gas. So the time of use of electricity and using electricity when wind and solar generate is really crucial for an electrical device, for consumer electronic products to be sustainable. And this phenomenon is going to accelerate. So we need to fight climate change. We are facing a significant energy transition. We need to electrify our usage, and we need to build renewable energy, which are low carbon source of electricity. So this is the trend of what wind and solar installed capacity will look like up to 2050. And we can see a drastic increase of wind and solar installed capacity, which means the variability of CO2 emission will also increase throughout the day. So it will become more and more crucial for devices to use electricity when renewable energy are producing, when there is clean electricity in the grid. Let's look at some practical example. We can look first at California. This is on this graph the share of solar production throughout the day on the 26th of August, 2024. And the dotted gray line is the corresponding CO2 emissions of the electricity produced in California during that day. So we can easily understand why from midnight to 6 a.m. there's no solar generation, and why from 7 p.m. to 12 a.m. there's no solar generation. And we can also see that the corresponding overall CO2 footprint of electricity in California for that day decreases significantly when the sun shines and when solar plants start to produce, and it increases significantly in the evening when solar production stops. The interesting thing here is that there's a ratio of 1 to 4 between an electrical devices using electricity during the day or an electrical devices using electricity on the evening. So I think this is very important to understand the scale of how the CO2 footprint varies throughout the day. Let's look at Denmark now. Denmark has a lot of solar and wind installed. So the green line here is the solar and wind generation accumulated throughout the same day on the 26th of August. Dotted line here is still the CO2 footprint of electricity. And we can clearly see here that an electrical devices will be powered by cleanest electricity in the middle of the day when wind and solar generation were at their highest on that particular day. And on the evening, around 11 p.m., no wind, no solar generation, CO2 footprint of electricity is about 8 to 9 times higher than during the day, at peak day. One last example with Germany, which also has a lot of solar and wind generation installed. On the same day, a lot of wind and solar at the middle of the day. No wind and solar generation in the evening, which leads to a very high CO2 footprint of electricity, which means that using electrical devices at this time would lead to electricity powered by fossil fuel. And in the morning on that same day, no sun, but a bit of wind generation, which led to a medium CO2 footprint. So I think that gives really the scale of how changing the time of use or charging a device can have a big impact on how much CO2 it emits. And by the way, this is also true for electricity prices. This is the same day, so the same curve of solar and wind generation. In red, the price of electricity during that day, and we can clearly see that the time of lowest electricity price were at midday when the wind and solar were at their highest. So renewable energy are cheap electricity, they are low carbon electricity, and there's often correlation between high generation of renewable energy and low price of electricity. So the footprint of using or charging devices changes over time. We've just seen that through a very practical example. So what does that mean for users of a consumer electronic devices or for a producer of electrical devices? Well, there's two options. Both come with risks. The first one is to do nothing, to build non-smart products, to let the product consume electricity at the will of the users. But this might lead to the device potentially consuming electricity at the wrong time or consuming electricity when there's fossil fuel generated electricity. The second option is to adopt the strategy of offsetting to 100% renewable energy. This can be done by end users either by procuring what is called green electricity contracts, or this can be done by manufacturers or companies by purchasing PPA or power purchase agreements or guarantees of origin. But we've just seen that there is not always renewable energy in the grid. So buying these certificates of origin or purchasing guarantees of origin, it's a contractual mechanism that allows a user or company to claim that the electricity they've consumed has been generated somewhere in the grid at some point by renewable energy, but it doesn't mean that the actual electricity was consumed by renewable energy at this specific time. So these two options lead to a risk for consumer electronic company, which is to affect the trust that the consumer put towards their brands. We know that users care about sustainability. They want to buy sustainable products. They want to consume renewable energy. They are attached to brands that have strong sustainability commitment. And we have evidence 55% of Americans would break up ties with brands that fail to uphold to green standards. 45% will switch to a competitor if their preferred brand was engaged in greenwashing. So the two options, either letting the devices consume dirty electricity or applying these guarantees of origin or 100% renewable energy mechanism, might affect customer trust, and as a company, you might even lose some of the customers. But there is a third option, which is building carbon intelligent devices. And these carbon intelligent devices will provide the best sustainability experience to end users. So what is a carbon intelligent device? So a carbon intelligent device is an electronic device or an electrical device that is actively reacting to the electricity conditions, actively reacting to the grid conditions, and adjusting its behavior in real time. A carbon intelligent device will know at all time what is in the electricity it consumes, what are the share of renewable energy, and it will also know predictively what is the CO2 footprint of electricity for the next 24 or 48 hours, and it will know predictively what are the share of renewable energy in the grid. So building a carbon intelligent product will not only be risk-free for a consumer electronic company, but it will also capture the willingness to pay from end users for more sustainable products. If you build a carbon intelligent product that makes end user consume mostly renewable energy, then eco-conscious users will be willing to pay for this product. 54% of consumers are willing to pay for more sustainable products, which means building a carbon intelligent product will also attract eco-conscious users, make your brand differentiate itself, and bring competitive advantage into the market. So what does a great sustainability experience mean for end users? So we talked about carbon intelligent devices, but how would users experience a great sustainability experience by using these devices? So there's two things. The first thing is engagement, and especially engagement with actionable, transparent, and real-time data. And we know that if end users are presented with dynamically changing data, they will engage with it. And we see that with stock exchange app, we see that with weather app, which provides dynamically changing informations. And we also see that with our own app, the Electricity Maps app, which provides insights about the CO2 footprint of electricity, which provides insight about the power mix and the share of renewable energy in the grid. And we have evidence from our users that people engage with it and they want to know when the CO2 footprint changes or when there's more renewable energy in the grid. So building a carbon intelligent product will also drive the engagement with your users because they will want to interact with the dynamically changing data provided. The second thing that makes a carbon intelligent product a great experience is automation. So we all care about sustainability, I believe. We all want to use renewable energy. We all want to buy sustainable products. But we expect and we want things to be automated for us. We don't want to have to take every day a decision on when is the best time to charge my device, when is the best time to charge my EV, or when should I turn on my washing machine or my dishwasher. So automation and automated carbon and cost reduction will lead to a great experience. And we can do that very easily by shifting time of consumption for a particular device to a time where either the cost of electricity is at the lowest, or either at a time where CO2 footprint of electricity is at its lowest. So here we have also an example for East Denmark, 29th of August, where we can see that typically around 6 to 7 p.m. where the demand is high, the grid will need to be, the electricity will need to meet the production, so we will need to meet the demand, probably by turning on gas or coal plant, which leads to an increased CO2 footprint of electricity. And we see that the demand is lower in the evening or during the night. So shifting the time of consumption or your dishwasher of charging your EV from 8 p.m. to 11 p.m. on that particular day could lead to 60% of less CO2 emitted for using that particular device. Similarly, this is the same day, same time. The price would be quite high around 7 to 8 p.m. However, charging the device or using the device at 11 p.m. will also lead to the lowest price of electricity during that day. So automation, automated cost, and carbon reduction is what users would expect on a carbon intelligent product. So this is what we think the next generation of sustainable products will be. They will be carbon intelligent. And this is already happening. So you might recognize here the Apple Watch. Apple has released their grid forecast feature, I believe end of last year, where they inform the users about what are the clean time on the grid, what are the cleanest time to use electricity, so users can make informed decisions about when to use their electrical devices. Samsung SmartThings have also launched last year their Carbon Insights feature and their Optimized Scheduler feature. They provide information about what was the CO2 footprint of using the home appliances. And they also provide a feature called Optimized Scheduling, where the SmartThings app will automatically choose what is the best time to use or to launch the devices, dishwasher, washing machine throughout the day in order to reduce CO2 emissions. I'm actually quite glad that a lot of home appliances companies in this fair are going into that direction to offer optimized scheduling and smart scheduling. BMW in the US have launched their Charge Forward program, which allows users to enroll and get rewarded when they charge their EVs at the lowest or the cleanest time. Monta, which is a charge point operator operating in Europe, they have launched 3 years ago their smart charging feature, which allows users, by shifting on this triangle here their preferences, and allow them either to optimize based on the cost of electricity, to optimize based on the share of renewable energy in the grid, or to optimize simply on the pure number of CO2 values. On a larger scale, Google have implemented their carbon intelligent computing platform a couple of years ago, where they take into consideration not only the time but also the location where there is most renewable energy in order to run some updates or some AI training in the data center that have the lowest CO2 emission and the more renewable energy in the grid. So they are shifting in time and in places the consumption of their electricity in order to optimize or to reduce their CO2 footprint and reach their net zero goal. So building these products will not be possible without a platform providing real-time and predictive electricity signals. We've seen that carbon intelligent devices need to know where does the electricity come from. They need to know what is the CO2 footprint of electricity in order to adjust their behavior in real time and predictively. So if you're a company trying to build a carbon intelligent product, you will need to manage an extreme data diversity and complexity. Electricity data are available throughout the world, but they come from hundreds of different data sources. They might come from CSV files, they might come from APIs, they might come with different data formats. Most of the time they come with delays, different time frequencies, they use different methodology, they have different quality guarantees, sometimes they are missing dimensions. For example, Japan only reports on nuclear and coal, I believe, and they only report on renewable energy once a year. So the complexity and the diversity of data you will need to collect is immense. And that's where electricity maps comes into play. We equip connected devices and carbon intelligent devices with global grid information. So we have done this work of collecting, harmonizing, standardizing all of this electricity data globally to provide it to our consumers and to provide it to carbon intelligent devices. We have a free app which is used by millions of people And people use it to get informed about the CO2 footprint of electricity, the share of renewable energy in the grid. And we have an API that is already powering millions of carbon intelligent devices, providing them with real-time information, forecasts of CO2 footprint, and forecast of renewable energy. So we are in the process of extending our coverage, but we already have a global coverage. We have harmonized hundreds of different data sources, and through our API we provide CO2 emissions, or gram per CO2 equivalent per kilowatt hour, as well as the power mix of electricity. Both historical data, real-time data, and we also have built machine learning models, forecasting pipelines to forecast up to 24 hours the power mix and the CO2 footprint of electricity. So we are proud to have partnered already with many companies that have built carbon intelligent products. We have worked with Samsung on their SmartThings energy features, helping them get global electricity data for them to launch their products. These carbon insights, reports, and these optimized scheduling features globally. And we also work with Google, Schneider, Microsoft, and others to help them build the products, the carbon intelligent products. So the mission of Electricity Maps is to contribute to decarbonization through data. We are an API provider. We provide data to our consumers. And we envision a world where all electrical devices contribute themselves to decarbonization by only consuming low carbon electricity. Thank you for your attention. Here is a QR code to our app if you're interested to have a look. And I think we have time for a few questions.